Okay, so welcome for this macro expansion, and we are going to see today the postings into the different tables of the macro. Let us consider this particular macro. Macro, as I mentioned earlier, when you write macro, the first line is always the macro. This is the indication for the macro preprocessor that the next statement is nothing but the macro header statement. That is nothing but the name of the macro. So clear name is the name of the macro. X and N and ampersand range, there are three parameters. X and N are positional parameters. Range happens to be the keyword parameter, and it is having the default value as a range. Okay. LCL ampersand M. So local variable we are declaring. This is nothing but the expansion time variable M. We set the value of M to 0. Then move ampersand range equals to 0. So we are initializing value of M to 0, and actually what we are doing here, inside the register, whatever is the register, that's the third parameter which we are using. So this will be replaced by arrange, depends upon the call. If the call just contains two values, then the third value by default will be taken as arrange. So arrange will be initialized to 0. If the call contains three values, then whatever is the register specified, that register will be considered over here for range. Now this dot more, this is nothing but the label inside the macro, which we call as the sequencing symbol. So dot more is the label inside the macro. We call it as the sequencing symbol. As I had mentioned, it appears inside the AIF statement. So AIF is parallel to the if statement. If M not equals to N, M not equals to N means the local variable or expansion time variable, we are checking that value. How many times the lines, it should go into the loop, that particular thing is described in this line. Okay, as long as the two values are not same, go and perform dot more. Dot more is nothing but move M ampersand range ampersand X plus ampersand M. So range is already 0. So move into the memory. Which memory? X and M. X plus M. Now whatever is the actual value for X, that will be considered. If the actual value of X is A will be considered. If actual value of X is B will be considered. So B plus 0 initially, then B plus 1, so on and so forth. It continues a fixed number of times. How many number of times? That is specified by the second parameter. So B plus 0, B plus 1, B plus 2. If value of N is 3, it will be making 3 consecutive locations 0. Okay, so what this macro is doing, it is making 3 consecutive bytes 0. Okay, so that is what is the macro. Now let us see how the postings are made into the different data structures of the macro. Parameter name table. Parameter name table, we discussed that we are going to maintain the formal parameters as well as the actual parameters. The formal parameters are written into the PN tab, parameter name table, formal parameters. AP tab contains the actual parameters. Actual parameters, whatever are the parameters appearing in the call. Now these actual parameters are to those values. PN tab, whatever are the values, those values will be replaced by the actual parameter values. Okay, so remember those two tables, PN tab and AP tab. They contain, one contains the formal parameters, the other contains the actual parameters. If you want, you can combine the two tables into one table called as AP tab. Okay, 2D, it will become 2D array then. EVN tab, expansion time variable table. Okay, so whatever expansion time variables we are maintaining. So there are two such things. We will see what is the difference in the two. EVN tab and EV tab. So when actual values are posted, I'll show you what is the difference in the two things. Then SSN tab, sequencing symbol name table and sequencing symbol table. There are again two things, sequencing symbol name and sequencing symbol. Okay, so a KPD tab is a keyword parameter default table. Now, it may happen that our macro may contain the positional parameters as well as the keyword parameters. Only the keyword parameters we can set default. So if there are any default values, just like in this macro, reg equals to areg, this value has been set as default. So keyword parameter default table, this will contain the default values. Okay. Now MNT, macro name table. The name of the macro will appear over here. The number of positional parameters will be here. The number of keyword parameters here. Number of expansion time variables. MDT pointer. MDT pointer means I told you that we are going to write from the third line of the macro. The remaining statement we will be writing into the MDT. Okay. So the third line to amend statement are written into the MDT. Now it may happen that there are 2-3 macros. So the first macro obviously will start from 0. The second may start from 12. Third may start from 23, something like that. So whatever is that pointer, this pointer is pointing to the macro definition table entry corresponding to this macro. Okay. So if there are 3 macros, 3 names will appear in MNT. The first name, suppose ABC, then its macro definition pointer might be 0. Second name, suppose DEF, then its entry might be starting, MDT entry might be starting from 11. So MDT pointer will become 11. So on and so forth. Okay. So KPD TP, keyword parameter default table. So which are the default values? So it is pointing towards this table. SSTP, sequencing symbol table pointer. Okay, so all those are the entries in the MNT, macro name table. Okay, so now let us have a look at the macro and let us see how the posting will be done. This macro label will be eliminated. Clear name is the name of the macro. So where should it go? In the macro name table. There are two positional parameters. So the number of positional parameters 2. This value will go into default value, KPD TP, KPD keyword parameter default value. So in that table, this areg will go. Okay. Then there is one expansion time variable. So likewise, every line is processed and the entries are made into the different tables. Let us have a look at the entries into the table. See here, xn reg, because the macro is containing 3 formal parameters, x, n, and reg. Reg value is set as default with default value areg. Okay. EVN tab, expansion time variable name table. So name of the expansion time variable is m. We have used LCL m. So m is the name of the expansion time variable. Then sequencing symbol name. .more is the sequencing symbol. So we write the name of the sequencing symbol over here. SS tab, sequencing symbol table. So this is actually corresponding to this sequencing symbol .more. From which line this .more starts is indicated here. Okay, so this is, suppose this macro is starting from line number 25 inside MDT. Now let us see first the values inside MNT. Clear name, the name of the macro. Number of positional parameters 2, x and n. Number of keyword parameter 1, reg. Number of expansion time variable 1, m. MDT pointer 25. This is pointing towards the first entry, wherever this macro has been written into the macro definition table. Okay, so this is 25. KPDTP, it is pointing towards the keyword parameter default value. So this macro is using range equals to a range as the default value, and suppose this is occurring at line number 10. So this value is 10. Okay, SSTP sequencing symbol table pointer, it is 5. Okay, so here you can see 5 SS step pointer, and inside this it is taking place at line number 28. So this move M, this is nothing but the dot more line. This is the label. Okay, now how we write the entries inside the MDT? Local, the third line. Okay, let me show you the third line, local ampersand M. So this will go first as the first line of the MDT. Then this will go as the second line, third line, fourth line, fifth, sixth, and up to M end it will be written. Okay, now LCL ampersand M. What we write for that? LCL expansion time variable number 1. LCL expansion time variable number 1. So go to the expansion time variable table, and whatever is the first variable, that is to be replaced here. Okay, then this expansion time variable number 1 is set to 0. Value of that it's set to 0. You can see here EV tab contains its initial value as 0. So M is the expansion time variable and it's initialized to 0. Move R P3. P3 is nothing but from here we are taking. Okay, read the PN tab, and whatever is the third entry, that is the third parameter from there, it's set to 0. Okay, now this is range and it is having default value a range. So ultimately a range will be set to 0. Move M P3 P1 plus E1. Now see P3, what is P3? Range, ampersand range. What is P1? X. Okay. Why we are writing P3 and P1? Because actually this will be replaced by those values, area, 10, average. Okay. So P3 will be replaced by average, P1 will be replaced by area, so on and so forth. Plus expansion time variable 1 means M. Okay. Then value of M set M plus 1. So it is incremented by 1. So earlier it was 0, now it becomes 1. AIF M not equals to P2. P2 is N. N is 10. So 10 times it may be performed. Okay, it depends how many times. It all depends upon the value of N. Whatever is the value of N, those many consecutive bytes we are initializing to 0. So that is what the macro is doing. Okay, I think you must have understood all those 9 data structures of macro. This is typically asked questions in the exams. Describe all the data structures of the macro. So what we have to do, we have to consider some example like this and show the postings of different things into the table, values into the table. Okay, so this is how the postings are made into the table. I think that is clear. Now we will see macro expansion. So there are 9 data structures of the macro. But out of that, some data structures are really very important. So what we do, we use the following data structures to perform macro expansion. We want to see how the macro expansion is performed. So AP tab, EV tab, macro expansion counter, AP tab pointer, and EV tab pointer. Okay, so macro expansion counter is set to 28. From where this 28 has been taken? see here, it will go on reading those lines, and what we will be doing is it will go on taking one line and will start its expansion. Only the model statements will appear in the expansion. What are the model statements? Those are nothing but the assembly language statements. So only the assembly language statements. Inside this macro, which are the assembly language statements? Move R. Okay, this is the first statement which will appear in the expansion. Move M. This is the second statement. Those values will be replaced by the actual parameters. This move R, move M. Okay, so actually only those things are appearing into the expansion, and maybe this 28, this is dot more, this is the label. So this line may appear several number of times, initialized to 0. We are initializing some variables to 0. So this will depend upon the second parameter. So maybe if the second parameter is 3, this line will appear 3 times. Okay, if the second parameter is 5, this move M line will appear 5 times. Rest all lines will vanish. Those are preprocessor statements. Those all will vanish. I hope you remember macro contains 3 types of statements. First is the macro prototype statement. That is nothing but the name of the macro. Second is the model statements. And third is the preprocessor statement. So here, clear name is the name of the macro prototype statement. Those first 2 and last 3 all are preprocessor statements. So those all are eliminated. Only those 2 lines will appear into the macro expansion. The second line may appear depending upon the second parameter n, value of the second parameter. So that is how the macro expansion takes place. Okay, so here macro expansion counter 28 is pointing towards that label. Now eptab pointer, actual parameter table pointer, it will point to that table of actual parameters, 3 values, area, 10 and average. evtab pointer will point to the expansion time variable table. Okay, so actually those 5 things are considered more often while expanding the macro. Nested macro calls, how they are expanded. There are 2 provisions. 2 provisions are required to implement the expansion of nested macro calls. 1, each macro under expansion must have its own set of structures, data structures, MEC, eptab, evtab, eptab pointer and evtab pointer. Those 5 things which I just mentioned, those, if there are multiple macros or nested macros, those will change with every macro. In the remaining things, you can write one after another. In the MDT, after the first macro definition is written, second macro definition can be written, something like that. But the actual parameters keep on changing, the expansion time variables keep on changing with the call of the macro. So those 5 happen to be the very important things. An expansion time nesting counter, this indicates how much is the nesting level. Okay, nesting counter greater than 1 indicates call is under expansion. Nesting counter equals to 0 indicates macro call is not in progress currently. So whatever, if the nesting counter is greater than 1, then it means this is the macro which is under expansion right now. So we are maintaining this nesting counter, and actually this, so that we come to know which is the call in case there are multiple calls, which is the call under expansion right now. Here we are discussing about nested macro calls. So inside one macro, another macro has been written. So the nesting counter obviously will not be 0, it is higher. So we will see the next slide. use of stack for macro preprocessor data structure. So for those 5 data structure, a runtime stack is considered, constructed. So normally what we do is the stack, it is a runtime, so dynamic stack, as and how you want it, the expansion of the memory will take place. Okay, now this is our normal stack only. I hope you remember our normal array based stack structure. Now this is similar to that, but normally what we do, we keep the upper side open. Okay, so the stack is growing in the upward direction. Now here you will observe, as per our books, it is mentioned that the stack is growing in the downward direction. The stack is growing in the downward direction. As and how a new macro comes, those 5 values, 5 data structures, we have to maintain separately for each call. So a new stack frame is generated and those different pointers are maintained. Now, this is the place up to which the earlier record was appearing. Earlier macro record was appearing up to this place. Okay. Now, when you say that we want to construct a new stack frame, so one new layer, one new compartment is constructed. This is termed as RB, record base. RB indicates record base. Now, what is the meaning of record base? When this particular stack frame is removed, where should it go? What is the earlier stack frame? So it should point to the end of the earlier stack. So that is what it is doing. This pointer is pointing towards the earlier stack frame. Okay, this is pointing towards the earlier stack frame. Now, 1 RB means RB, whatever is that location record base, plus 1. Here what we store? Macro expansion counter. RB plus 2 means the second position after RB record base. What we store? The EV tab pointer. Now this is pointing towards the actual EV table, expansion time variable table. Okay, and the third thing is the actual parameter table. So the actual, whatever are the actual parameters are written over here. So that is how actually one stack frame is created whenever you are trying to expand a new macro call. When your expansion is over, this complete stack frame will be removed and there will be earlier stack record base, earlier MEC, earlier MV tab, because macro inside macro. So the first one might be here earlier, the second one is appearing here. So it is as and how the macro is invoked, means the macro calls appear, the new stack frames will be constructed. Now what happens? The innermost macro always is expanded first. So this outside, this here, whatever is appearing here might be the first macro and this is the second macro. So the innermost macro is this macro, second macro. This will be expanded completely and then the pointer is returned to the earlier. This full stack frame is removed from the memory. Okay. So reserve pointer, the same things have been mentioned over here. Reserve pointer, what is it? 0. That is, it is nothing but the record base, starting point of the new macro record. MEC, macro expansion counter, it is written at the first position after the RB plus 1, whatever is the next position, that position MEC will be written. Then the third one will be EV tab pointer, fourth one will be AP tab, whatever are the actual parameters, those all are listed. Now remember, this may differ from one call to another call. It may happen that the same macro has been invoked 2 times with different actual parameters. So this indicates the current actual parameters for the current macro under consideration. EV tab, expansion time variables. So this also changes with the invocation of a new macro call. So those 5 things are listed. Now what are the actions at the start of the macro expansion. Toss equals to toss plus 1. See, actions at start of macro expansion. When the macro expansion starts, what happens? What are the statements which will be executed? Toss is nothing but the top of the stack. Top of the stack equal to top of the stack plus 1. I'll show you in the diagram. See, earlier this was top of the stack. Earlier this was top of the stack. Now what we are doing? Top of the stack equal to top of the stack plus 1. So it is pointing towards this particular position. Top of the stack comes over here. I told you this particular memory stack is expanding in the downward direction. Let it expand in any direction. It hardly is the pictorial representation, whether you are showing it vertically, horizontally, downward, upward, whatever. Ultimately, the same is the effect. Okay, only diagrammatically it changes. If you show it upwards or if you show it downwards, hardly matters. So toss, top of the stack was here. Remember, this diagram is drawn in the downward direction, growing in the downward direction. Okay, so this is top of the stack was here, then top of the stack plus 1, it comes here. Okay, now we will see top of the stack star equals to RB. So what we are doing? It is pointing to the first previous record base. It should point to the previous record base. We are just incremented by 1, move to the next position, and toss star equals to RB. What happens? Here, this pointer should point to the earlier record base. This pointer should point to the earlier record base. Why? Because when this full memory is removed, I told you this is dynamically allocated memory. It grows and shrinks as and how it is required. So when this is removed, this where to go back, which will be the RB, new record base. So that will be nothing but the earlier record base. So this points to the earlier position. Okay, so that's what has been shown over there. RB equals to toss. RB equals to toss. It comes over here. Okay, and now what it does? 1 RB equals to MDT pointer entry of MNT. So store the MDT pointer, store the actual parameters, and store whatever are the expansion time variables. All those things are to be stored. Okay, so I think I'm having one example. See here. This was the first macro call. RB was here. Then 18. Okay. X and Y are the actual parameters. X and Y are the actual parameters. We will see here. The second one is EV tab pointer, and the next is AP tab, actual parameters. So the same thing, actual parameters are X and Y. Now the top of the stack, when this particular macro is under consideration for expansion, the RB is here, pointing towards this position. Top of the stack is here. Remember, we are growing in the downward direction. Now, there is a nested macro call. So one more macro appears inside this macro. Inside the macro under consideration, we find out one more macro call. So in the body of this macro, we find another call. So what happens? This is the diagram for that. So RB becomes RB plus 1. And what to store here? This will start pointing towards this record base, earlier record base. Then whatever are the values we need to write over there. Macro expansion counter value and EV tab and AP tab. So see here, This is macro expansion counter. This is pointing towards the MDT entry in the MDT table. Okay, so it is starting at 75 location. This was starting at 18th position. Now, this is also having XY, same macro has been invoked with the third parameter as B rich. Okay, with the third parameter as B rich. Now, when this has to be done, this is under expansion. This particular stack frame has been generated. Earlier, only this much was there. That is, only this much part was there. Now, this new stack frame has been generated. And when this is done, expansion is over, this full stack frame is removed. And again, the stack frame remains under consideration is this. Okay, so that's what was shown in the table. At the end of the macro, what to do? Toss equals to RB minus 1, RB equals to RB star. What is RB minus 1? If it is here, RB. Okay, so top of the stack should become RB minus 1. Make it pointing towards this position. See here. Because we want to remove this much frame. So top of the stack should become RB minus 1. And RB should become wherever RB is pointing to, this position. So this will become new RB. So that is what is done in the expansion of the nested macro calls. Okay. Pass structure of a macro assembler. Macro assembler, as I mentioned, you can combine all the activities together. Which activities? Macro preprocessor plus assembler. Either you write two different softwares, macro preprocessor, one software, second software, assembler, or otherwise you write the two things together, which we call as macro assembler. So macro assembler will be performing all the tasks of the preprocessor plus assembler. All the tasks of the preprocessor, that is eliminating the macro calls plus generating the symbol table, generating the target code, whatever are the tasks of the assembler. So all the tasks. Now, you can write it in 3 passes. You can write it in 3 passes. The first pass will contain macro definition processing, SIMTAP construction. Say one activity from the macro preprocessor, other activity from the assembler. Okay. Then perform pass 2, what you can do, macro expansion will be performed. Then I hope you remember this 2, 3, and 4 are nothing but the assembler tasks. So those are to be performed. So the first thing is the expansion of the macro. This is preprocessor task. Here also the first one was the preprocessor task. Second one was the assembler task. Even here, first one is the preprocessor task. 2, 3, 4 are the assembler tasks. Now what remains for pass 3 is the target code generation. Okay. Pass 2 is large in size since it performs many functions. So just like I think you remember we discussed, you can write 2 pass assembler. So there also we discussed that variant 1 and variant 2. So if you use variant 1, pass 1 is overburdened. Same thing is happening over here. Pass 2 in this case is overburdened because all the activities you are maintaining in pass 2, you are performing in pass 2. So all the data structures of macro preprocessor and conventional assembler need to exist during this phase. So pass 2 requires a lot of memory. Comparatively, pass 1 and pass 3 are hardly anything. So much of the task is performed in pass 2. Pass 2 is heavier. Okay, so if you use those kinds of passes, this is one way. Actually, you can, if you want, you can shuffle the things and make the passes balance. Okay, so this is 3 pass macro assembler, which is performing the task of preprocessor as well as assembler. The pass structure can be simplified if attributes of actual parameters are not to be supported. The macro preprocessor would then be a single pass program. Okay, so this may be simplified if attributes of actual parameters are not supported, then the task will be simplified. Macro preprocessor will become a single pass program. And what you can do here, the activities of the macro preprocessing you can perform, and those three are the assembler activities which you can perform. It means instead of going as per the earlier schedule, pass 1, pass 2, pass 3, what we can do, you can have pass 1, which is containing macro preprocessor plus assembler activities, and pass 2 is generation of target code. So that is how we can write the macro assembler or macro preprocessor. Okay, we will stop over here for today.